In this video, we're going to cover Unit 5, Learning Set 4, Logarithmic Functions, Day 2, and the objective is to graph and solve logarithmic equations. The first thing we're going to talk about is the natural log function. A logarithm with a base e is called a natural logarithm and is written as ln. So e, which represents the exponential base, and remember, like pi, that is a never-ending number. And ln just indicates a specific natural logarithm. So it could be written also as log base e to the x. So if you look at this first piece, log base e x could now be written as ln x to represent the natural log. Also, the inverse, just like we've learned previously with logarithms, would just be x equals the exponential base e to the power of y. And just like our graph that we looked at previously, on the left we have the exponential graph of y equals e to the x, and on the right we have the graph of y equals ln to the ln x. And you will see if we put them over each other, they are mirror images of each other over the y equals x line, which means if they're mirror images over the y equals x, then they are inverse functions. So graphing a logarithmic function and its inverse. So we want to graph the function and identify its key characteristics. F of x equals 2 times log x minus 2. And remember, if there is no number here, that means that it is a base of 10. And that is an assumption that we always have. So first of all, remember, when we're looking for the domain, we want to look at the x minus 2 to help us figure out the domain. And that x minus 2 has to be greater than 0. So we would set it up, x minus 2 is greater than 0. Move the 2 over, and x has to be greater than 2. So that means our domain in interval form is going to go from 2 to infinity. Now to graph this, I would use Desmos. So we have 2 log x to the 2. So I will use the keypad, put in 2, and then remember, under functions miscellaneous, the log has no base, so we want to use the one that just says log. And it was to the x minus 2. And as you see over here on the graph, they have graphed it for us. Okay, so, and notice if our domain starts at 2, then we have a line that goes down where x equals 2. That would be where our asymptote is. We would have a vertical asymptote at x equals 2. And here is the graph that we just saw. The range, if you remember, the range is going to go forever in either direction, so it's all real numbers. In an interval form, it would be from negative infinity to infinity. And as we stated, our vertical asymptote is along the line x equals 2. So the next step, now that we know the domain and the range of the logarithmic function, we want to find the inverse of f. When we're solving for the inverse of something, we switch the x and the y. So in our equation, the f of x is y, and the x minus 2 represents the x. So we want to switch the x and the y on our inverse. And we want the log to be by itself, so we need to divide both sides by 2. And we end up with x divided by 2 on one side equals log y minus 2. Now at this point, we want to use our conversion that we know. We know that y equals log base a x, and we can switch it to x equals a to the y. Okay, so what we would do here is I would look at this and identify and say y equals x divided by 2. A, because there is no base listed, is 10, because remember we said if there's no base it's always assumed it's 10, and the x value equals y minus 2. So when we rewrite this, in the x place is y minus 2, a is 10 to the x minus 2 power. And then we continue to solve for y by adding 2 to both sides. So the domain should be the range of our log function, because remember they're inverses, so that means the range and the domain flip. So the domain will be negative infinity to infinity, and our range should match our domain, so it has to go from negative infinity to 2 because it's the opposite. So let's look at a graph of this. So we have y equals, so I'm going to graph it on the same one, and we have y equals 10 to the x squared, so 10 to the, x divided by 2. And let me go back and look, and then it's going to be plus 2. And if we look at our graphs, we can see that they are the opposites. And if we were to draw a line, it would have a y equals x. They would be mirror images of each other. So here we'll do y equals x, and I'm going to put the dash line. And you can see that they are mirror images over the y equals x line. And here is the graph of the -1. And it still has a vertical asymptote of x equals 2. So let's look at another example. Let's look at log base 5 to 3x minus 4 equals 3. So we're going to solve this like an equation. And first thing we need to do is we need to change it to exponential form. And like I said, remember exponential form is where y log a x becomes x equals a to the y. So we know that a is 5, that's our base, x is 3x minus 4, and our y value is 3. So when we put it in, it's going to become 3x minus 4 equals 5 to the third, because we're changing it just like we did before. So the next thing we want to do is we want to take our 5 and cube it. So we get 3x minus 4 equals 125. add 4 to both sides. 3x equals 129. And then x equals 43. So our solution set would be 43. Now we can check this. We can check this by plugging it in. So if we plug in 43 for x, log base 5, 3 times 43 minus 4 equals 3. Log base 5, 125 equals 3. And if we convert this, we take the base of 5, I'm sorry, not the base of 5, the base of 5 for the letter A, set x equal to 125, y equals to 3. That means it would be 5 to the third power equals 125. And if we multiply 5 times itself 3 times, we do get 125. So we know that this solution is correct. And the last example is we're going to look at the exponential base to the 3x equals 7. And for this one, we want to look for an exact answer. And for an exact answer, you would use the logarithms. And that would be in your answer. So we want to change it to a logarithmic. So we're going to go backwards. So that means we're going to go from x equals a to the y to y equals log base ax. Now in this case, we have a logarithmic base of e. So we know that we can use the natural logarithm. Okay, so x equals e to the y would become y equals ln x. Okay, so that ln 7, because remember x is on the other side. In this case, for this equation right here, x equals 7 and y equals 3x. And our a is e, but we don't have to list it because it's a natural logarithm. So the next step would be to divide both sides by 3. That gives us the exact solution. If we were to put this in our calculator, we would get approximately 0.649. So that is an approximate solution. It's not exact. So for this solution set, you would just list your answer as ln the natural logarithm 7 divided by 3.